Okay. Let me just quickly check for the audio. Uh, okay, cool. So now let's start our discussion on introduction to system design. Okay, let's start our discussion on introduction to system design. Now, what is system design? See, whenever you go to the internet and you search for what is a system design, you generally will find a lot of different problem statements. Okay, these problem statements will vary from a lot of products. Like you will find something like design YouTube, design Netflix, design Uber. Yeah, these problem statements are pretty good and will give you a good perspective on what to expect when you are actually working. But generally, as one engineer yourself, one software engineer yourself, there is a very less chance that you will be designing the whole YouTube at some point of time. Generally, you work in teams and generally you have some specific part of the product that you technically try to target, right? And even if you read these system design articles and videos and whatever resources you try to follow, these resources also tend to solve one specific type of a problem when they say design Uber or design YouTube and so on. Like as a software engineer yourself, generally what's your I would say weekly progress generally happens is that you are given some kind of a feature. That feature may be already solved by somebody, some senior engineer. Otherwise you will be responsible to solve the technical details about that feature, right? Generally it doesn't happen that you just start straight away your coding I would say effort on the corresponding feature. At some point of time, either you or some senior engineer or some other engineers from other team will be doing some kind of a solutioning. Whenever you hear this word solutioning, this is the same thing that we refer to as the design of the system. When we say design of the system, we actually refer to the corresponding solution to the problem that you are facing. Okay, this problem can be very small problem, right? I'll give you a very small example, which was something that even I worked with. So when I was working with Google Pay, then at that point of time, we had a very simple problem that we wanted to build a screen. In that particular screen, we wanted to show some static pointers, a static image, and a button. Feels like a very simple problem, right? Like if you will give this particular problem to a college student, they will just rush towards it and they will say, oh, we have to just build a screen in Flutter. That's a very pretty simple scenario to go for. We will just add some static 4 or 5 pointers. Whatever image we have to give, just tell it to me where to place it. I'll place it and add a CTA button, that is click to action button. And that's it. That's how generally college students will try to target it. But when you actually work on I would say scaled products and try to engineer some kind of a solution, you have to think in a more broader perspective. Let me tell you what kind of a broader perspective I'm talking about here. So how about the 4 pointers or the 5 static pointers that we have, we want to very frequently change it. You will say if we want to very frequently change it, we will just go to the code and we will make a code change altogether, right? But there is a problem. To publish your application, now I'm talking about an Android or an iOS kind of an application, right? If you make any code change and you want your users to see the code change, at that point of time you need to republish your app, you need to put a new version of the app. And that's not what you generally do. For changing some static data, you do not release a new version of the app like whenever you want, right? So we wanted a solution where the actual I would say static text of the app, whatever is written on that screen, can be changed very frequently. Now you might think that okay, that's a simple problem, why not just make a API call altogether and fetch the data from the corresponding backend. Good solution, right? But there is one small problem again with that. What about internationalization, right? For example, like generally when you work on applications, you don't just want to work on a single language. Maybe you want to have a multilingual kind of language where your whatever is the text written on the screen can get converted to other language also if the overall system setting has been changed to another language, right? In that case, from the server, you might have to prepare multiple language based I would say text and feed that on the server side, store it somewhere on the database or maybe some configuration files, and then fetch it back on the front end. Again, that's an extra added effort. I'm not saying it's not possible. That's an extra added effort, right? So you can see, like, we solved one problem, then there was another situation. We solved this situation, then there is another situation, and so on, right? So when you actually work with scaled applications, you will realize that there are a lot of corner cases that you have to figure out first. This phase of figuring out things, where you figure out that, okay, how the solution should work, what can be some corner cases, what our user behavior is like, what is the scale of users we are looking at, what kind of data we are playing with, what kind of nature of the application we are playing with, a web app, a mobile app, just a backend service, what it is. This kind of a figuring out phase or the solutioning phase is technically your system design. And in interviews, we try to mimic this same scenario in kind of like 55 minutes or 1 hour kind of a discussion, right? So when you're learning system design, think it about as you have been given a single specific aspect of the product to solve. Generally, you will not like solve everything in a product. You will be solving one specific problem, right? And then you'll be doing a solutioning, right? Of course, in an interview, that solutioning will be discussed in that 1 hour only. But if you are actually working as a software engineer, probably you need to write something that we call as a design documentation. In that design documentation, you write everything, like the requirements, what solutions you are thinking about, what are the solutions you discarded, why you discarded them, what is the solution you are accepting, what are the pros and cons of every single solution that you have, what's the timeline that you're looking at, what are the challenges. And apart from that, you also add some low level coding details that probably if we are going with this particular solution approach, these are a couple of coding solutions, or I would say the code pointers that we are going to change. These are some of the classes and the functions that we are going to actually implement, and so on. And you prepare this kind of a whole design document. You actually have a design review meeting where you just discuss all of these design documentation all together, get it approved, and then your coding effort actually starts. So this phase of designing the system, problem solving the system, figuring out the solution of the system is technically what we refer to as system design. How many of you guys are able to get this point? Say yes or no in the chat. So with Mishra, generally we do not do that. Why? Because otherwise people will just put random messages here and there and you will be just distracted. Trust me, you will get hang of it altogether. Okay. It will be uploaded, Samad. Make sense, everyone? Okay, cool. In that case, let's start. Now you know what system design is, right? You know what is basics of system design. Now, whenever we talk about any particular system, right? Whenever we design any particular system, there are two very important things that we tend to identify. One is called as a functional requirement, and one is called as a non-functional requirement. These are very basic and simple things. Okay, like even if you have done computer science engineering kind of thing, then there must be a subject of software engineering kind of stuff. There also functional and non-functional requirement you might have heard, but don't worry, I'll tell you. Okay, so what is functional requirement? In a simple nutshell, functional requirement means actual features that you are going to develop. Like for example, the example that I gave, that we have to implement a screen where we have to show a couple of pointers, an image, a CTA. That's the functional requirement, that the CTA should be configurable, that when we click on the CTA, we should be able to go to some XYZ pages, right? There should be some internationalization supported, and so on. If you take a look at some other applications, like let's say Uber. So what can be a functional requirement of a very basic application like Uber? That the people or the user should be able to request a ride. They should be able to feed a starting point and an ending point. The driver should be able to receive the request of a ride. They will be able to accept a ride, right? The user and the driver can maybe chat. At the end of the ride, they will be able to, let's say, pay from, let's say, some wallet service. The driver will be, before accepting a ride, they will be actually shown a probable total price of the ride, and the user will also be shown a probable cost of the ride, and so on. These are kind of like the functional requirement. Functional requirement refer to the actual feature that you have to develop. This will be the actual set of features that any end user can come to your application and actually try out. Are you guys able to get this point? Is this point making sense, everybody? That what is a functional requirement? Like what do I mean when I say functional requirement? Everyone, say yes or no in the chat. Are you guys able to understand what's a functional requirement? Okay. So just think about it. If let's say I ask you to design a very basic version of Uber wallet. Okay. Let's say I talk about Uber wallet. Okay. Now, if I talk about Uber wallet, what can be some basic functional requirements of the Uber wallet? Right. If I talk about some basic functional requirement of the Uber wallet, then a few of them can be: users should be able to load money from credit card or debit card. Maybe this can be a load money can be a feature. Can I say that? Okay. And these requirements I'm writing, assuming that if you have a Uber account, you by default have a wallet account, right? Sometimes some applications can ask you to onboard on a wallet as well. Sometimes some applications have the scenario that when you make their account, you do not have by default the wallet. You have to onboard yourself for the wallet. I'm assuming generally we don't have to do that for Uber, at least what my experience is. So like if you have an Uber account, you have an Uber wallet. So people should be able to load money from their credit card or debit card. Apart from that, users should be able to see the current balance, right? Users should be able to see the transaction history, like to whom like all other I would say situations where they have technically paid through this Uber wallet. Okay. Users should be able to pay another Uber user or another user with this wallet, and so on, right? These can be some actual features. These can be some actual features that we will be actually implementing and the users will be able to use. This is what we refer to as functional requirements. Make sense? Krish, it's already shared. Please try to rejoin in case you are not able to see the shared screen. Everybody is able to see the shared screen. Got it? Guys, I guess you are able to see the shared screen, right? Yeah, when I say you should be able to pay, that's technically withdrawing money, right? Or maybe one thing can be when you have loaded the money, you should be able to bring back the money on the original source. That can also be a feature. I'm just giving an example that what will be a functional requirement altogether. Is everybody able to understand what's a functional requirement? This is kind of like the set of features. Okay. Generally, if you see how companies work, is that a basic set of functional requirements is generally given to you by probably a product manager of your team, right? They're going to prepare something like a PRD, product requirement document, where they actually mention what, like with a particular feature, what is the expectation, what should be done with that particular feature, what are the possibilities that can go ahead with that particular feature, so on and so forth, right? For example, let's say you are actually preparing this Uber wallet. So all of these kind of functional requirements will be actually thought by probably your engineering managers or probably your product managers. How do they think about it? That's again a very different discussion altogether. It can be based on the business requirement, it can be based on the market fit requirement, but that's not our I would say headache to actually go for. No, not really. Like for again, in an MVP, there might be a case that very few functional requirements are there which might not even qualify for an MVP, right? And there can be so many functional requirements that can qualify for something beyond an MVP. Shashank. Yes, Abhishek Singh. So Abhishek is asking, like, do we write design docs like HLD and LD before we actually code a particular solution? So yes, we do that. Like in a lot of companies, we do that. Okay, got it. Now this is what functional requirement is, and that's pretty straightforward. Now comes the non-functional requirement. Non-functional requirements are those requirements of the system which are not the exact crucial features. These are not your features that you are going to actually use in a particular application. Instead, non-functional requirement actually refer to the behavior of the system. How your system is going to behave in different situations, how the overall system should be built altogether. Apart from the functional requirement, what other things you need to take care of while building a system is your set of non-functional requirements, right? This is something that you have to keep in mind. We'll talk about like a lot of non-functional requirement detail, but just to give a few pointers. For example, you discuss or you think about the scalability aspect. of the system, that how many users you are probably looking at, how many requests you are actually looking at, so on and so forth. You're going to think about the availability of the system, that how available the system is. All these terms I'm going to talk about in detail, that what availability is and everything. But I'm just giving an example. You talk about the scalability, you talk about the availability, you talk about the maintainability, and so on, right? And so on. Maintainability, right? And so on, etc. We'll talk about all of these in a moment in more detail, but these are kind of like different non-functional requirement that probably you have to think about. And again, whatever I'm talking about here is not just with respect to interviews. This is with respect to your actual final work as well. Now, talking about in an interview, like how you should proceed in an interview. If let's say there is a system design interview, how you should proceed. I'll tell you what I follow. I take care of a few major functional requirements. I do not go with a lot of functional requirements. Why? Generally, in an interview, you have 1 hour. In 1 hour, people do not expect you to build a product which is still being built since like last 20 odd years, right? So in 1 hour, they expect that you are sensible enough to understand that you just have 1 hour, and you are sensible enough to decide what are some of the most crucial features that you want to discuss, so that you go through the interview, right? So it's up to you. Generally, you would like to take 2 or maybe 3 major features, a couple of side features. Even if you do not have much time, then you can just have some one-liner discussions on those, and that's it. If the interviewer expects you to work on more features in those 1 hour, then you can maybe ask. It's all about having some discussion with the interviewer that, hey, I believe we should go forward with these 3 features first. And if there is more time left, then we can talk about a few more features. In case the features that you have proposed, the functional requirements that you have proposed to the interviewer are not the main functional requirements that the interviewer is actually looking at in your final design, then he or she will automatically tell you that probably you can skip this feature, and instead, how about you think about a new feature altogether. This is how you should technically approach. So you have to take a balanced approach. You have to take I would say, a balanced decision that how many requirements you need to go for. Make sense, everyone? Is this point making sense? Okay, cool. Now, talking about non-functional requirements, let's talk about them step by step. So the first, and I believe a pretty important non-functional requirement, is availability, right? Availability. Now, with the term itself, probably you are able to understand that availability refers to how much the system is available. But what do we mean when we say the system is available? Right? What is the meaning when I say that the system should be highly available? Like, now we are not talking about any particular feature, right? We are talking about the nature of the system, right? That, okay, this whatever feature you are building, this should be highly available altogether, right? What do we actually mean when we say high availability? Anyone? Less downtime. Very good. Chandan says less downtime. Very good. It should be online and serve request all time. Okay, that's great. Our system should be up and running all the time. Makes sense. No single point of failure. Okay. Site should be always up. Yes. So when we say availability, then technically we talk about the time for which some service of our infrastructure is accessible to the clients and can be operated in normal conditions. Okay. So availability is the percentage of time for which some service or feature of the whole infrastructure is usable by the clients, and can be operated in normal conditions. Okay, can be operated in normal conditions. Okay, so I'll give you an example of a few highly available systems, right? For example, if you see for example, any kind of a streaming service nowadays, right? Let's say something like Hotstar, right? Or something like JioCinema, right? Or maybe even Netflix. Like, and you can think about any specific feature for them, like let's say the live streaming part. Now, of course, if there is a World Cup that's going to happen, Hotstar or Geo Cinema, all these systems will expect that the live streaming aspect of their application should be highly available, right? That means in case when a match is going on, a World Cup match is going on, and maybe specifically some India's match is definitely going to happen, they will expect that okay, a lot of users are going to come. They don't want their users to be in a situation when they are not able to see the live stream for a few minutes, right? Or a few hours. Their system is down, the system is not available, they're not able to see the live stream altogether, right? That's technically your availability aspect, right? So systems expect that okay, you should have as high availability as possible. But generally we can actually even quantify this, right, based on the level of nines. So a lot of times, even in your design discussions in your office, you will actually hear about how the level of nines in terms of availability, right? How many of you guys have heard about it? Like, you might have seen that okay, we are looking at four nines or five nines availability, right? These kind of terms you might hear. Okay, so to define availability in a single, I would say, word, availability is directly correlated to your uptime, for how long your system is technically available. Okay, and you can measure it in terms of nines, you can technically measure it in terms of nine. So you can see there is a small chart that I have. Okay, you can see here, I believe this chart is visible to everybody. I believe this chart is actually visible to everybody. Can everyone see this chart? Guys, is the chart visible to everyone? Say a yes or no in the chat. Okay, cool. So this chart in front of you actually tells you the availability percentage, right? In terms of nines, Okay. So when you say two nines, 99 means two nines. Okay. So here 99 means two nines. So whenever we say two nines, this means we are looking at a 99% availability. What do we mean by 99% availability? So when we define this percentage of availability, we are defining them with respect to the downtime that we can probably suffer, right? The probable downtime that we can probably suffer. So what downtime we are looking per year? So when we say 99%, then we are probably looking at 3.65 days in a year where the system overall on an average can be down, right? Because if you have to be 99% available, then there is a chance that for 1% of the whole year you are unavailable. So that's 3.65, like approximately 3 to 4 days, maybe your system is down. Again, same thing per month, same thing per week, and same thing per day. You can see this is the configuration. When you say three nines, we are looking at three nines, right? When you are looking at three nines, that means we are looking at a 99.9% availability. What do you mean by 99.9% availability? That we only have a chance of 0.1% downtime. That means 8.7 hours. This is technically very less of a downtime that you are going to actually look at, right? Per month, just 43 odd minutes. Per week, maybe 10 minutes. Per day, 1 minute. This is like extremely less downtime that we are looking at. And it's a pretty good availability for a lot of systems, to be very honest. Like if you see majority of the systems, if they are able to achieve something like a 3.9 or a 4.9 like of availability, they are actually doing pretty good, and so on. So this is like 4 nines, this is like 5 nines, this is like 6 nines, and so on, right? So if you have a very like extremely highly available system, you want the downtime to be as low as possible, right? For example, let me actually show you one interesting thing. So AWS, the cloud service provider AWS, has got a lot of services. Okay, so let me show you one. So let me log into my AWS console. You can see, I believe my AWS console is visible to everybody, right? Okay. Now, if you actually, let's say, search for a couple of services like S3, S3 is again a storage service which stores blob, right? Blob objects, right? And maybe you can look at DynamoDB as well and so on. Okay. You can see Amazon S3, like if you see, they sell Amazon S3 as a very high scalable. You can see Amazon S3 is an object storage service that offers industry leading scalability, data availability, security, and performance. Data availability means that if you're storing your data on S3 and you want to like very regularly fetch it, you are looking at a very highly available system if you are actually storing that in S3. Okay. So, and if you see DynamoDB, you can see, let's see what they talk about the availability here for DynamoDB, or we can maybe search availability DynamoDB. Okay, DynamoDB is a NoSQL DB provisioned by Amazon itself. Okay, Amazon DynamoDB service level agreement, right? So if you carefully see the May 4, 2022 service level agreement, right? Then you can see global tables and standard SLA. If you look at global tables, for now you can understand that to store some data in DynamoDB, which is some kind of a NoSQL provided by Amazon, right? You have some table structure, which is, we just call them table, but it's kind of like some documents which stores key value pairs. We can talk about that later. But if you carefully see, they are providing an agreement here that monthly uptime percentage, right? It's greater than or equal to 99%, right? Monthly uptime percentage greater than or equal to 99%. You can see they're actually defining that probably what kind of a downtime you might suffer in the worst case. Okay, it's not like every month definitely there will be some downtime if you have stored your data in DynamoDB, but kind of like they're defining it in the worst possible case, right? And why I'm showing you these Amazon related services, because there is an interesting case study with Amazon that actually happened in 2017. Okay, so this is a very interesting case study which is around the outage of Amazon S3. You can see this is an article from Gremlin, the 2017 Amazon S3 outage. This was one of the very interesting case studies to understand about availability of the system, that if you promise a certain amount of availability of a system and you're not able to like provide it, what kind of chaos can it actually create? So you can see on February 28, 2017, a problem occurred with the Amazon S3 simple storage service. This same S3 service that I was actually showing you guys earlier. This one, Amazon S3 blob storage service. Okay. In the US East 1 region. Okay. So if you know about AWS, they have actually divided this. So they follow a global infrastructure. Like they have actually divided the whole earth into different regions. Okay. And few AWS services are global services, like you can use them across the globe from any data center and any region. Few services are region specific. S3 is a region specific service. So they have a region US East 1. For example, if you carefully go here, you can see there are a lot of regions that are mentioned here. US East 1 is this one. US East North in Virginia. This is the region. Okay. So this region that took down a significant percentage of internet for approximately 4 hours. So there was some problem in this particular region, S3 service, and this was down for approximately 4 hours. The problem was so severe that for a while, Amazon couldn't even get into its own dashboard to warn the users and instead used Twitter to give updates. So you can understand how severe of a, I would say, failure they were actually looking at. Making matters worse, it seemed that half of the internet was using S3 in the impacted region without multiple region failover schemes in the place. Now just think about it. A lot of companies are actually using S3. S3 is a regional service. Like when you create a S3 storage, probably you are creating it in the US East region. Now S3 provides you the service that you can back up your, I would say, S3 storages in other regions as well. But a lot of companies were not doing that. And a majority of them were having their storage in the US East 1 region, which made things worse. A large number of significant websites were impacted. If you want to take a look, here's just a list of companies and services that were impacted according to these articles. Adobe services, Amazon's own Twitch service, Atlassian's Bitbucket service, and you can see a lot of important names. You can see Heroku was affected, Expedia was affected, Medium affected, Microsoft's hockey app was affected, and so on. You can see a lot of different applications were indeed affected because of this, right? So what really happened, you can see, you can read about this if you want to see in a nutshell. Then here some would call this a typo. The root cause of what ultimately impacted the two other services in the region, the S3 index subsystem and the S3 placement subsystem. The index subsystem manages the metadata and location information of all S3 object in the region. So there is a S3 subsystem that actually manages the metadata. Metadata is the data about the data, right? And the location information of S3 objects. What is an S3 object? If you store a file in S3, we refer to that as an object, which is necessary to serve all the get, list, put, and delete request. The placement subsystem manages allocation of new storage and requires index subsystem to function properly to correctly operate. Okay. The blast rate, and there was a change that happened here. If you carefully see, one of the input to the command was entered incorrectly and a larger set of servers was removed than intended. So they were trying to actually make changes to this index, and due to some wrong command entered, they actually removed more than what they expected. This is kind of like in a nutshell, but you can read more about this overall article here, right? Moral of the story is that availability of the system refers to the downtime. There might be a case that on your system, some upstream systems or some other systems are also dependent. So if you have a dependency, like other systems have dependency on you, and you are expected to serve on a very high availability, you need to provide measures of making sure that your system is as highly available as possible. How many of you guys are able to get this point? Say yes or no in the chat. Don't worry, in case you don't know about S3, we are going to cover S3 in the lectures for the AWS aspect, right? But is this case study making sense? Yes, there might be still applications which might need like more than like 5 nines and everything. But again, it depends like what kind of a scale you are looking at, right? What kind of different application that you're looking at. It can be dependent on that, but yes, there can be some applications. More questions, guys? Last point. Okay, so last point, I was just talking about what caused this outage that we are looking at for 2017. So S3 internally is, again, a lot of logic must be empowering S3, right? An important part of that logic is this index subsystem, which actually stores the metadata about the objects or the files that you technically store in S3, right? This is very much necessary to serve any kind of a get, put, delete, or list request. So list is a type of request also that Amazon technically supports, right? So you can say they were trying to make a change in this index, and they actually added a few more entries than they actually expected. Okay, why downtime occur? There can be a lot of reasons for downtime. First, maybe there is a bug in your code. Second, maybe during some specific operations you did something wrong and that caused the downtime altogether. There can be a lot of reasons for a downtime. Are you able to get this point? Like, for example, you can see here, right? Maybe the load that you anticipated, as Sumit mentioned, the load that you anticipated was way less than the actual load, and your systems were started throttling. That might be a reason why you are not able to get it. Okay. Okay, how these nines are calculated? Okay, so we technically provide a service level agreement for these nines, but if you want to still calculate like it mathematically, you can you can take the total uptime that you are assuming your system will be always there, divided by the uptime plus downtime. That will be the overall availability percentage that you can have. Because like few downtimes you can yourself think, no, that let's say there can be some maintenance, right? There can be some maintenance, scheduled maintenance that you are going to have for your system. At that point of time, you definitely know there is going to be a downtime. Can I say that? Right? If there is, let's say, some kind of scheduling, like maintenance that you have, maybe you do some backups, you do some replications, you do something specific, and you are expecting the system to be down at that point of time. So you can predefine that, okay, that there will be this much amount of time the system can be down. For example, like websites like IRCTC and everything do a lot very regular maintenance, or banking websites do a very regular maintenance at night, right? So they not just like tell their users, but also the upstream services that, okay, they might be down for a couple of minutes here and there. Got it? So like if you want to calculate, this is like a straightforward formula. Like you can do something like uptime divided by uptime plus downtime. Okay. And you just multiply that with 100. Okay. That can help you to calculate the percentage. Make sense? Um, we are talking about the case study for why availability is important. In case you have defined an availability for your system in terms of the nines, why it might be important for you to actually follow that. No, P90, P99 is not the same of the same thing that we are talking here, Archit. That's different. That's technically your percentile metric. That P90, P99 can be associated to anything, right? It can be a latency, it can be something else. We are not talking about that one here. Yes, like if you know about that time, you can include that. Do we need to take care of backup or failover system in case? Yes, so AWS do provide that. That's why you can see there is a dedicated SLA that they are already providing, right? That the system might be down for like this much amount of time. Okay, but again, you cannot just depend on cloud services. You also need to ensure one simple thing, that you are making a system as robust as possible, such that in case something goes wrong there, you have something ready. For example, I'll tell you an interesting case. For example, let's say you have a couple of servers. Okay, you have a couple of servers, right, in a particular region deployed, right? Let's say this is server number 1, this is server number 2. Okay, you have a couple of servers, and let's say these servers like do some kind of a computation, right? Some kind of a computation they technically do, like maybe they do some data analysis, they do some data aggregation, something they are technically doing, some important crucial service they are doing. Now you cannot just expect that, oh, we have more than one server running, so even if this server goes down, we have the another server running all good. No, maybe the problem is that you are running both of these servers in the same region, and the whole region goes down, the whole cluster of the region goes down. Then what? In that case, you might need to have a backup instance, right? In maybe some other region altogether. You might need to have a backup instance in some other region, right? Just like this. Here also you'll be having a backup instance. Now just think about it. What can go wrong here? In case this particular cluster, in case this particular cluster goes down, you will switch to the another cluster. Now what do you think? This switching can take time, right? Because maybe you need to boot up this cluster, you need to set up all of these servers, you need to take some time to reroute all the requests here. It will take some time to set up the whole project and run your servers. It can take up some time, right? So do you want that? Or again, maybe you want that, maybe you are okay with that, maybe you are not okay with that. If you're not okay with that, then probably what you need to do is you need to follow something like a active model. What is an active model? Active model. In an active model, you kind of like keep a warm instance ready, right? You kind of like keep a warm instance ready. You are going to keep this system all set up, and you are going to have a logical switching mechanism. You can write your own logical switching mechanism, such that let's say if there are some jobs that are technically running on this particular cluster, and this particular cluster goes down, we can immediately just switch to the another cluster, or maybe there is a third cluster altogether, and maybe we can load balance between the other two clusters altogether. So again, you do not just depend on the cloud services and their SLA. Whatever product or whatever project you are working with, there can be a case that you have to take measures yourself, so that your downtime is as low as possible, right? Like for example, like I'll talk about load balancers in a minute, but let's say you have a load balancer that is like forwarding requests to multiple application servers. What if that load balancer goes down? Your application servers are still running, maybe the load balancer has some issue. So in that case, you need to have a backup ready, and so on. Why does the region go down? The region can go down due to some maintenance going on. Maybe some actual code bug happens. Maybe there is some natural disaster that happens altogether, so on. Okay, I guess anything beyond 3 nines is pretty available, Safi. Yes, Amazon's a lot of service do provide that. Like you can, of course, check or Google it in case if you want to have a proper list. Yes, so you can say when we say availability in a nutshell, if in one word, if I have to explain it, I'll call it uptime. Okay. Warm. I'm talking about warm. Warm means like you don't have to like boot up it from scratch and you have to set it up from scratch. You have everything ready. It's just that it's in an idle state. And the moment you want, you just switch the traffic from the primary instance to the backup. Got it? Make sense, guys? Everybody. That's what availability is. Are you guys able to understand that why do we care about availability and what can actually go wrong in availability? Okay. Now, it's not like availability is cheap. Now, it's not like availability is something that you can just have for every system. If your system doesn't need availability, maybe you don't want it that much. Why? Because it can incur some cost. To make your system highly available, the need of the infrastructure can actually add up extra cost to you, right? If that cost is too much and you do not need that much amount of availability, then maybe you don't need it, right? So you need to always keep an eye on the trade-offs that, okay, we want to make the system available. Do we even need that much amount of availability or not? Right. For example, let's say the system just does some periodic things every 3 hours or every hour or something. Then maybe you can have, instead of making that system highly available, that let's say every hour, whatever job we have to run, maybe you can have a retry mechanism implemented that even if the system is down for, let's say, a couple of hours, we can have a periodic 15-minute retry going on. And once the system is up, the retry will actually fulfill. Or there are other mechanisms that you can have for the retries, like something like a dead letter queue or something. We'll again talk about that later. But again, I'm mentioning that if you don't need that much amount of availability, then maybe you should not focus a lot on it because it can actually incur some cost in terms of in the infrastructure. Are you able to get this point? Okay. So when you say highly available systems, when you say the systems are highly available systems are actually engineered in a way that you have to maximize your uptime, right? You have to minimize your failure points, whatever single point of failures you have, whatever I would say maintenance failures can happen, whatever redundancy is there, whatever cost optimizations you can do. After doing all of that, if you're still able to maintain very highly available system, that's pretty great. uh Such a system we are doing, there must be a point here everything crashes. What will be the point everything, uh like if you see, let's say with respect to aws follows something like a global infrastructure. The regions have dedicated data centers which are like separate from each other. You cannot expect like the whole earth is going to be bombarded with something, right? Maybe something happens in the region of Singapore, but maybe the Europe region is going to be pretty safe. So it's your responsibility as the user to keep your replicas and backups ready. Are you able to get this point? Like, if the whole earth is bombarded with, like, let's say some meteor, like, I don't think your availability is the first thing that you will think of. So, of course, we keep few situations in mind. Make sense? Are you guys able to understand what availability is? I'll put this link of this article. Pretty interesting article to actually read. Okay, so you can read about how what Amazon actually did and so on, right? I just wanted to like once I will like talk about S3, I'll talk in more detail about this outage again, but I just wanted to give you guys a brief initially. So I'll just put it here. Okay, so I'll just put this link here. Okay, cool. Make sense? That's availability for you. Got it? Why is availability? Because it's not a feature. Like you just discuss the feature aspect in the functional requirement. All the non-functional requirements are the behavior. So that you segregate your, I would say, things properly. Got it? Yeah, you have to design for that, but probably not every coding element of your coding, or like not your every coding effort is going to rely on that. Like coding effort end to end definitely includes everything around your functional requirement, but some coding effort might include non-functional requirement, and maybe some non-functional requirement might be something that how you set up the infrastructure, how you set up the remaining steps of the system. This is probably why you keep this as a non-functional requirement. Yeah, sure. Samad, there you go. Got it? Generally not, but again, it's a theoretical thing, right? So at the end, if your feature works, it's good. Arun. Okay, cool. Now, the next aspect is maintainability. Next aspect is maintainability. This is pretty important and pretty straightforward. Like you don't have to like bang your head a lot in order to understand maintainability. Maintainability is that you design your system in a way that it's overall maintainable, right? If you want to add up some features, you are able to easily add it up, right? If you want to, let's say, restructure some existing piece of code, you can do that. For example, a lot of time companies migrate from their existing tech stack to a new tech stack. Your system should be built in a way such that if you're doing some kind of a migration, the due to the migration, the other aspect of the system is not getting affected, right? And so on. So you can say maintainability is kind of like a principle that ensure that the system can evolve easily. You can modify it with as less disruptions as possible. Okay. So maintainability refers to making the system as evolvable as possible without major disruptions. Without major disruptions altogether, right? And generally, maintainability is a long-term thing, right? You do not like achieve maintainability in one go, right? Maintainability takes a lot of effort, right? Starting from how you structure your code, like whatever final code you are structuring, starting from that to how you structure the overall architecture, from there to there, like everything gets included in the maintainability part, right? Like how you structure the code, how to structure the code, right? How to monitor the application, right? How to, uh, let's say, achieve modularity in the architecture. All of these things refers to maintainability, right? And maintainability is kind of like simple efforts. I'll just give you one more example. So let's say that you are writing a code. Let's just take a front end example for an instance. Let's take the same example of that same screen that I was talking about. Now, one way to write your code would be you prepare that whole screen and like you have somehow figured out how you will get that text, image, and everything. Let's talk about that CTA. Very simple, very small thing, but very useful. Now, one way that you can code your screen is that whenever somebody clicks on that CTA, you are redirected to a specific single screen. Okay. But maybe you get a requirement that this particular screen is embeddable at multiple places. We want to be in a situation that this text and image and this CTA, this screen is reusable at different places of the app. So we want that CTA button to be reconfigurable easily. We don't want to be in a situation that we need a very heavy code change whenever we want to integrate that screen at a new place in your application. For example, let's say for a new user onboarding, you need that screen. And then for a new, let's say, payment instrument registration, you need that screen. Let's say for a new type of account also, you need that screen, and so on. Like at multiple places, you need that screen. So that screen should be kind of like in a plug and play. It should be coded in a plug and play fashion. So it's important how you structure the code as well. Then you talk about monitoring the code. Like if let's say you are doing some migrations or you are like let's say improving something in your overall system, then you need to also monitor that whatever code changes or whatever changes in the system that is happening, it's not disrupting a lot of things, right? So you need to set up some kind of a monitoring in place as well. Are you guys able to get this point? Okay, so monitoring has a lot of aspect with the actual coding, or you can say the LLD aspect, right? But overall, how you design, like for example, if you want to have a microservices based architecture, right? Because let's say some aspect of your systems require to be in a situation that let's say you go forward with the microservices architecture. Now, how you structure your microservices? right? Having microservices can help you to keep things modular. I'm not saying microservices is the final solution to achieve maintainability, but I'm giving you a situation that maybe microservices is the thing that you technically need, right? Because maybe the same code piece or the same set of APIs is required by a lot of upstreams. Instead of having that in your monolith, maybe you can have a separate microservice for that, and so on. And a lot of companies nowadays actually use the microservices architecture to make their system as maintainable as possible. And it gives them technically an opportunity also to make sure that if a particular part of a system needs any specific tech stack or needs some specific amount of scaling needs, or they have some specific things that they need to do for some specific part of the app, they can do that. For example, think about it like Amazon Pay. Like Amazon Pay as a, I would say, module is reusable in the Amazon shopping app as well, and it's reusable in the Prime Video probably as well, right? But you don't want to be in a situation you have coded the whole system in a way that it's very tightly coupled to the Amazon shopping app, right? You might want to have it in a situation where you can reuse it at other places as well, right? So like basically what you need to ensure is that your system is highly extendable and maintainable. You can add up a couple of features, you are able to evolve your system, but you should not disrupt a lot of things in the longer run. Like pretty simple and straightforward thing. Make sense? Are you guys able to get this point? Like it should be easily changeable. Now just think about it. Like as I mentioned, currently, let's say you started coding whatever service you are coding, right? It, you can say it helps you to achieve extendability, Varun. And initially you started coding the whole service with, let's say, MySQL, which is an RDBMS. Later you realize that you were not having a situation or a use case for MySQL, and let's say you want to migrate to a new database. So have you structured your code in a way that this database migration is simple enough, right? That can lead to maintainability. Make sense, everybody? Is this point making sense? Say a yes or no in the chat. So you need to keep your code base simple. You need to keep your code base extendable. You need to have proper monitoring setup so that in case any fault and everything is occurring, you are able to get that all together. Yes, Varun, you are thinking in the right direction. Got it? You can say a good part of it. Prakar, as I mentioned, like setting up microservices, not just your LLD, but yeah, setting up a right code structure is definitely your LLD. Okay. Make sense, everyone? Say a yes or no in the chat. Okay. Now we are going to talk about a very important term, that is scalability. And I believe a lot of you might have already heard about it and a lot of you already know about it. Scalability. Scalability is the ability of the system such that it can handle increasing amount of workload without compromising your performance. Okay. So scalability is the ability of your system to handle increasing amount of workload without hampering the performance altogether, right? So for example, if let's say at any point of time you started to look at like a lot of user requests coming up, whether your system is able to handle that or not, right? And in most of the system design interviews as well, you will be expected to have some situation where the scalability of the system is expected to be very high. Mostly what at least I have observed, there I have never seen anybody asking a question that scalability is not a concern generally. Maybe there are some specific situation where people can actually ask you that, but mostly in 99% cases people will actually expect you to have the design of the system that can handle a lot of scale. When we say it can handle a lot of scale, that means it can handle a lot of user requests, it can handle a lot of workload that you can technically get. Okay. For example, just think about it. Like let's again talk about those streaming services, right? So whenever let's say there's World Cup, of course the amount of influx of users who are continuously live watching your live stream is very high, right? Compared to maybe any other test series or any other test match or something like that, right? So in World Cup, things can scale up a bit, right? You can have a lot of users, and specifically, let's say if there's a very anticipated match, let's say something like India Pakistan match, or let's say India Australia match, something like that. So there will be a lot of users who are going to technically come up. Your system should be ready enough, your system should be prepared in a way such that your system is able to handle the increased amount of workload, right? You should try to architecture your system in a way that yes, in case a humongous amount of workload starts coming up, you are able to handle that. Okay, you can probably test your system prior hand, such that okay, like you cannot, like generally you do not wait, right? That like I have architectured the system, and when something will happen, then at runtime only we will test it. No, right? You can actually do something kind of like a load testing or stress testing, right, to your system, to actually see how your system performs in increased amount of workload. Okay, for example, so there is a interesting case study from Hotstar again. Like I'll share you again. I always talk about this particular video from a Hotstar cloud architect, where he talks about how they actually handle the scale of Hotstar. So I'll explain you the situation in a bit more detail. Okay, so like just think about it. And again, I'll help you with the video. You can later watch it, but I'll tell you some important pointers from there. So you can search for Hotstar cloud architect, Hotstar cloud architect videos, and this video you can watch, scaling Hotstar for 25 million concurrent viewers. This is a very, I would say, interesting video, right? But I'll tell you some important pointers from the video. Right? So for example, this is the Hotstar app. Okay, now just think about it. Like I'm telling you one of the use cases that the author of, like, or the speaker of this video is talking about. So let's say this is the homepage of Hotstar. Okay, generally on the homepage of Hotstar, you see your recently viewed, okay, your recently viewed, your other recommended suggestions, and so on, right? This is what you see on the Hotstar. Now just think about it. You will be having some set of APIs, some set of servers, which will be serving you your recently viewed and your recommendations and everything. Can I say that? And let's say there is a certain amount of load that this system is expected to handle. All good, no problem. Now Hotstar is also supporting live streaming, right? So let's say somewhere here, there is a button where the users can actually redirect them to the live stream. Okay, and this is the live stream screen. This is, let's say, the live stream page. Okay, now let's say the India Pakistan live stream match is going on. Okay, and let's say, or maybe India Australia live stream match is going on. Okay, and let's say there was a very anticipated batsman, like let's say something like Virat Kohli or somebody, who actually starts to bat. Of course, what will happen is you will start looking at an increased amount of load, right? You will start looking at an increased amount of load, and you have technically anticipated that as well, that okay, in the live stream area we can have a lot of users that can actually start coming up and see the live stream. Okay, and a lot of people join the live stream from the homepage. A lot of people join the live stream from the notification panel as well. Like sometimes there is a notification that drops that okay, Virat Kohli is about to bat 5 sixes in a row and something. These kind of like interesting notifications they send, and then you click on those notifications and you are directly landed up onto the I would say live stream page. Everything is going good, but let's say suddenly Virat gets bowled. Then there will be a good amount of people who might not immediately continue watching the match. They'll be like, oh, our favorite player is like out for now, we'll come back later. So, and let's say there's a huge majority, like for a player like Virat Kohli or a player like Dhoni, there's a huge majority of people who will be like, oh, there is nothing left to watch. So what will happen? A lot of people will just kill the app directly. That's okay, right? If you just kill the app from your mobile phone, that's okay. But maybe a lot of people presses the back button. A lot of people actually press the back button. And let's say this back button lands up them to the home page. Now just think about it. 25 million concurrent users, and let's say if you take half of them, or let's say a bit less, maybe 5 million concurrent users, they immediately press the back button in a few seconds of time. All of those users are going to land on the home page. And on the home page, you have your recommendation service APIs, which are sending you the recommendation. You have your last watched APIs, which are sending you the last watched shows. all of those humongous traffic will immediately start hitting these APIs. And if these APIs are down, the Hotstar homepage will not be able to load. And those people who are not even interested in watching the match probably will not be able to actually see anything else on Hotstar as well. So you can see this is a situation that you thought about, right? This is a situation that can come up. It's not like it's obvious that this is going to happen. This is a situation that you think that, okay, what will happen if a lot of users start coming? People gradually come. That's okay. But we cannot expect that they gradually go out also from the app. They can, maybe there will be a sudden downward spike in your users because maybe their favorite player is gone, or maybe the match probably is just now on a deciding factor that, okay, now it's a one-sided match. Then a lot of users might shift to another screen. And if these APIs and these servers are not scaled enough or not ready enough to cater this amount of load, then it can actually cause a bottleneck. And considering that this is the homepage, a lot of catastrophe can actually happen. So this is like situations where scalability and thought process around scalability, that how much scalable system and what are the aspects of the scalable system you have to take into consideration, comes extremely important altogether. Are you guys able to get this point? Are you guys able to get this point? Okay, so watch this video as well, like pretty fun video to watch. You will get, maybe there will be a couple of things that you will not understand after the first half, but the first half of the video is like pretty interesting stuff to discuss. Got it? But yeah, this was like, this is one of the aspect that they talked about. And the guy will actually show you a couple of graphs as well, that this is what happens when Dhoni comes to bat. This is what happened when Dhoni gets out. This is how we used to be ready. And one more interesting thing the guy talks about. So like in the same video, the guy talks about one more interesting thing that leads to good scalability in terms of the system of Hotstar. The guy says that, like, if let's say we are looking at users coming up, right? There can be a gradual increase in users that happens generally from the start of the match. Okay, that maybe there are like 10 lakh users, then there is 50 lakh users, then there is, let's say, 1 CR users, and so on. If there is a gradual increase in the users, let's say we can boot up more servers. I'll talk about more around booting up more servers. That's okay. But what if there is a sudden increase in the number of users? There is not a gradual increase in the number of users. There is like a sudden spike, like a humongous sudden spike. Why? Because maybe Virat Kohli is about to hit 200 runs in one day cricket. Everybody will just like, not even those people who are not even interested in the match will also like immediately start coming up. And there is a sudden spike. In that case, I would say the speaker talks about the fact that Hotstar cannot spend a lot of time in expecting that, oh, now more users are coming up. Now we will boot up more machines which can actually cater those requests, right? So what they keep is, they keep a lot of warm instances already ready, right? So that they can be just immediately provisioned. Because cold booting a brand new machine, setting up your project, auto scaling that we refer to, I'll talk about auto scaling in a minute. Auto scaling that we refer to can be a bit time consuming. Like maybe it takes a minute for your auto scaling instances to turn up. 1 minute is too much for a match where Virat Kohli is gonna hit 200 ODI runs for the first time or second time or something like that. Okay, so these kind of situations also you need to be ready, right? And a very important aspect in terms of scalability are how you scale up your system. So there are two important principles around scaling your system: how to scale up a system, or how to scale up a system. So there are two types of scaling, I would say scaling, that we generally look at. One we call as vertical scaling. One we call as vertical scaling. One we call as horizontal scaling. Okay. What do you mean by vertical scaling? Vertical scaling means that, let's say you had an instance of a machine, right? And you improved the capability of the machine. For example, let me show you. So if you go to AWS, you go to AWS EC2. EC2 is the AWS service with which you can, what do you say, technically provision brand new machines. Are you guys able to get this point? This is the aspect of AWS using which you can provision brand new machines. Make sense, everyone? Say yes or no in the chat. Okay, so this is a service with which you can provision brand new machines. Okay, cool. Now let's say you go to your EC2 dashboard, you click on a launch instance. Okay, you can see there are a lot of instance types mentioned. Okay, AWS provides you a lot of different instance type. Like for example, if you take a look at this instance type, it has a 1V CPU, like one core CPU with 1 GB RAM. Pretty decent. Like their one core CPU and 1 GB RAM will be far more powerful than your own personal laptop's one core CPU machine. But now let's say you want to increase the capability of a machine. Then you can increase the capability to, let's say, 2 core CPU and 4 gigs of RAM. Or maybe you want to go even further, then maybe you can go for a 16 core CPU and 32 gigs of RAM. What do you mean? What do I mean? I mean that in order to scale up a system, there are two strategies. The first one I'm talking about is vertical scaling. Vertical scaling means that, let's say your server was deployed on a machine. Now you want to increase the capability of the machine altogether. That I get a more powerful machine. If I get a more powerful machine, then technically that powerful machine will be able to take up more load. As simple as that, right? If let's say previous machine was a relatively weaker machine and now I have a more powerful machine, in that case the powerful machine will be able to definitely take up more load. So what will you do? You will be having, let's say you have a T2 micro instance. T2 micro is a 1 core CPU and 1 GB RAM instance. It's available in the AWS free tier. You are already having your servers running. Now you are able to see that probably there is a sale that's going to happen and a lot of users are going to come up on our platform. So what you're going to do, you want to vertically scale up your system. How do you vertically scale up your system? Very simple. Go to any other larger instance that you feel suits your capability, like suits your, I would say, requirement. Take up that system and deploy your server into that new, more powerful machine. Once the deployment is done, probably you test it. And then what you do, you just redirect your traffic, reroute your traffic from the older machine to the newer machine. And that's it. That's your vertical scaling. But the problem with vertical scaling is that there is a limit to the maximum power of the machine that you can achieve physically, because these are actual machines available on the AWS data centers. So there's a limit to the maximum power of a machine that you can achieve. First thing. Second thing, very powerful machines are very costly. It's not like you are an engineer, so cost doesn't matter to you. Cost matters to you. So you need to make sure that if you are vertically scaling things up, then cost is also kept under consideration. Because just think about it. Like if you want a more faster, like let's just take a very simple example of hard disk and solid state drive only. Let's say you buy a 1 TB hard disk. That like for a personal usage. I'm talking about a personal usage. That costs you what? Probably 3,500 INR, right? But now you, let's say, buy a 1 TB SSD. Now SSD is more powerful, faster. That 1 TB SSD will probably cost you 6,000 INR. And a 2 TB hard disk will probably cost you just maybe 4,200 or 4,500 INR, just 1,000 rupees more from the 1 TB one. But the 2 TB SSD will probably cost you 9,000, maybe probably double, right? So it's not like you just want to increase the capability of your machine. Increasing the capability of the machine can cause serious cost inclusions. So if costing is something that you are like very sensitive about, you need to keep in mind like how you are actually doing the vertical scaling. Is this point making sense to everybody? Okay. Now the second aspect is horizontal scaling. Horizontal scaling is simple. Horizontal scaling is simple. Instead of increasing the capability of one machine, you deploy multiple machines of mediocre capabilities, right? That's your horizontal scaling altogether, right? So in horizontal scaling, what will you do is you will be deploying multiple instances of the same server, and what will happen is you will attach something that we call as a load balancer. You attach something that we call as a load balancer in front of these. Okay. Now what load balancer is going to do is, load balancer is also going to be a machine. This is also going to be a separate machine. Load balancer is also going to be a separate machine. What this machine is going to do, now this machine is going to accept the request on behalf of your application servers. And this load balancer is going to reroute your request. This load balancer is going to reroute your requests to different application servers. How do you want to reroute? That rerouting might be dependent on the algorithm you want to choose. Maybe you want to have a round robin. You want to have a first come first serve. Want to have a weighted round robin. In different algorithmic mechanisms, you can set up your load balancer so that it reroutes the request to multiple application servers actually. And in this way, what you will do is you will have a fleet of servers ready to cater your request. So if more request comes up, you distribute that request across your multiple servers so that they can actually work more properly. Right now, how can you get a load balancer? If you want, you can set up your own load balancer using something that we call as Nginx. Okay, like you can use Nginx, which is a great solution for having a load balancer, or you can use something that we call as AWS own elastic load balancer, ELB, which is a very powerful tool to set up a load balancer out of the box. Is this point making sense to everyone? Again, how to know whether you want to switch between vertical and horizontal scaling? Again, it depends. Do you have enough, like, are you seeing a significant cost increase due to vertical scaling? If yes, then go with horizontal scaling. If no, then go with vertical scaling, because what's one good thing about vertical scaling? Vertical scaling is simple, and simple is good, right? So until or unless you have a lot of cost integrations going on and you have a physical capable machine that is suitable for your main needs, go with a vertical scaling solution. If cost is something that's going to grow up humongously, maybe because you are working at a scale of something like Netflix or Uber, then maybe, of course, horizontal scaling can be something that you might need to take care of. Yes. Now, one interesting thing that can happen is even the load balancer can be a bottleneck, or this can be a single point of failure. This load balancer in itself can be a single point of failure. So if you're looking at a very high available system, then you can do one thing. You can have one more backup load balancer in a warm state, right? And a few more load balancers in a cold state, right? So you can prepare kind of like a few backup load balancers so that in case one load balancer goes out, you can immediately switch to another load balancer. In this way, you will be kind of like having a very proof mechanism that in case your primary load balancer goes out, you have a secondary load balancer ready to serve your request altogether. You can set up your gateways also inside that. Like it depends how you want to set it up. Make sense? I'll be also uploading some lectures where I will also show you how you can set up your load balancer using Nginx and how you can set up your load balancer using Amazon's own elastic load balancer. Like if you go to EC2 instances, you can see this part, right? Auto scaling groups and load balancers. I'll be uploading a couple of lectures on how to set up your load balancer and how to do horizontal scaling yourself. Okay. Now with horizontal scaling, there is an interesting aspect of auto scaling. What is auto scaling? Auto scaling means, let's say you are using some cloud provider like AWS or Microsoft Azure. Auto scaling means that you provision your systems on the cloud in a way that if more users and more requests are coming up, these cloud services will automatically provision new instances for you. They will automatically provision new instances for you. That's auto scaling. In auto scaling, what will happen is, let's say initially, for example, initially you have 2 instances running because you are looking at a very average load. But let's say suddenly a lot of new users started coming up. What AWS is going to do? AWS is going to provision a brand new machine for you. It will automatically set up your project inside it and attach it to this load balancer so that now this load balancer can redirect your request across these 3 instances. If more, let's say, users and more requests are coming up, then it will provision, let's say, one more instance altogether and so on. And let's say now you see a downfall in the number of requests, then it will automatically kill a couple of instances as well. So you can define the policies that, let's say, if you take a look at like the CPU usage goes beyond 60%, that's the trigger when the new instance need to be automatically provisioned and attached to this load balancer. If things go back less than 60%, you can delete the new instance. You can also configure in these cloud services that what is the minimum number of instances at any point of time and what's the maximum number of instances, because you don't want to be in a situation that AWS keeps on provisioning machines for you and unlimited number of machines will cost you a lot of money, right? So you can even put a upper cap, you can put a lower cap, that how much minimum number of machines and how much maximum number of machines can go. This is what we call as auto scaling. So in auto scaling, the cloud service providers automatically provision new machines, set up your project inside that, and attach it to your load balancer. You can do it very easily using a couple of scripts that you have to configure, and that's it. But the problem with auto scaling is auto scaling can take up a couple of minutes because Amazon has to provision a new machine for you, set up your project. To set up your project, it might need to set up other few things. Let's say you have a Node.js project. So it needs to first of all set up Node.js in your machine, probably npm in your machine, then download your project, build your project, then run your project. So it maybe it takes maybe 30 seconds or a minute. So it can take up some time. So auto scaling is good, but if you do not even want to be in a situation, then you can do two things. One, you can keep a more safer trigger that, let's say, instead of going to 90% CPU usage or 90% RAM usage, maybe trigger a new instance at 60% CPU usage, so that you have at least some time before more traffic comes up, you have more machines ready. Or you do something like how Hotstar also does. You keep a few warm instances. Keeping a few warm instances is good because they are ideal. They're not taking a lot of requests as of now. But in case you see a sudden spike, you can immediately just like bring your warm instance and add it to your fleet. This will save up a lot of time that might get killed in auto scaling. And it depends. Maybe your application has a use case which is good with auto scaling. Maybe your application has a use case which is not good with auto scaling. Let me tell you. So Book My Show recently was doing all of those tickets with Coldplay, right? Coldplay ticket selling was happening. Then Diljit Dosanjh ticket selling was happening on Zomato and everything. Now, if I am, let's say, if let's say you are an engineer at Zomato, you know that because there is a ticket sale for Diljit Dosanjh and there's a lot of hype, and this is the first time ticket sale that is going to happen on Zomato, we know that there will be a lot of users. We know that there will be a lot of users. So we will pre-prepare ourselves and we will pre-provision a lot of instances that are up and running already. You do not wait that, okay, when the user will spike up, then an auto scaling mechanism will trigger and provision a new machine and then set up a project for us. Right. So again, it's your situation. So this situation for Zomato, where let's say Dua Lipa's ticket booking is there, or concert ticket booking is there, Diljit Dosanjh concert ticket booking is there, you can pre-prepare your instances. But let's say it's Diwali and a lot of people are actually ordering sweets from Zomato and everything. That is something that is gradual, right? Maybe Zomato will see a lot of uptick during Diwali week. Maybe they will not. So auto scaling can be good at that point of time for, let's say, the Zomato, I would say Blinkit servers and everything. So it depends on situation to situation. When do you want to keep auto scaling enabled? When do you not want to keep auto scaling enabled? All of these are engineering decisions that you have to yourself take. Are you guys able to get this point? You can do something called as a load testing, right? There are a lot of load testing tools like K8, which can help you identify that probably in a 30 seconds or in a minute, how many requests your system is able to serve. Then you have to anticipate that, okay, probably we have, let's say, X number of registered users on the platform. We'll be having, let's say, 2x more new users on the platform because it's Diljit Dosanjh's concert. And then you anticipate that, okay, if everybody starts requesting, then in a minute, how many requests are going to come up. And because you have already done the load testing and you know how much one server is able to take the load, based on that, you can decide how many more servers you can pre-provision. It's math. So we'll talk about back of the end. So there will be a topic back of the envelope, I would say, designing, where we will try to understand that how you can do these kind of interesting calculations as well. Karthik Garg says if autoscaler downscale the pods, that can be an issue. No, you can decide when it downscales as well. So you can define every single policy altogether. Make sense, everyone? Do you understand what exactly is this scaling mechanism? Also, vertical scaling is also sometimes called as scaling up. Horizontal scaling is also called as sometimes as scaling out. Just terminology. Got it? How can we handle a request coming to an instance which is turning off? It's not like the instance is turning off and it is still attached to the load balancer. It immediately gets detached to the load balancer, so no more request comes up there. And if the request, if there is already a request being served, load balancer will automatically handle it. So that's why you use a managed service like Elastic Load Balancer from AWS to handle these situations. Like, I believe even a cloud service provider one is good. It's just that if you do a self-managed one, Gagan is asking, like we can also do auto scaling self-managed. Yes, you can do that. You can use something like Kubernetes, which is actually turning up a lot of Docker containers for you, and inside that Docker container, you are running your servers. Problem is self-manage. Self-management, if you can do, you have enough bandwidth, you can handle that kind of situation, it's good. Otherwise, these cloud solutions are pretty good at their job. What is Nginx? Nginx is a library that you, or you can say a software using which you can set up your own load balancer in case you do not want to use a existing load balancer from AWS. Yes, I'll be uploading a lecture on how you can set up your own load balancer using Nginx and how you can set up your own load balancer using AWS ELB. Is auto scaling horizontal? Auto scaling generally refers to horizontal scaling only, because you define policy how many more machines you want to add in the fleet. Got it? When should, again, guys, Nginx is something that you will again manage yourself, set up yourself. So if you want to set up things yourself, it's good. It's kind of like you can use your cloud service provider for infrastructure as a service. When you use them for infrastructure as a service, you manage everything yourself. But let's say a few things you use platform as a service. So let's say ELB platform as a service. So what will happen is you don't have to get into the hassle of maintaining the load balancer, writing the algorithmic logic or configuring the algorithmic logic. Everything will be automatically done for you. So if you want everything automatically done for you, you can do that. So it depends again your situation. What do you want? What is your team is good with? Have you ever managed your own load balancers? If not, then probably using an auto provisioned or automatically like AWS managed load balancer is better. You get introduced to the system, you understand the system well, and then maybe you move. In case AWS ELB is not flexible for you, you can write your own load balancer. No, Nginx is pretty simple. You just have to configure a file and boom, it's done. Abhishek. If you want to have a wrapper, again, that's your choice, but Nginx is pretty powerful in itself. Got it? Okay, rate limiting is different, load balancing is different. Rate limiting is that if, let's say, from one particular IP, you are getting a lot of requests, which is unusual. And you want to stop it, that's probably one example of rate limiting. Load balancing is that you have a lot of requests and you want to distribute that load in a couple of different instances. That's load balancing. It's kind of like, let's say you have a lot of work for you and you delegate that work to a lot of juniors under you, working under you. That's load balancing, right? Make sense? Gagan, I have been into situation where people handle both. So again, it depends. Again, as I mentioned, it depends on what kind of a team you are looking at, and what's your, like, I would say, overall company and like the broader team follows. But I have seen people using self-managed instances a lot nowadays. Are we going to code our own load balancer? We will be setting up our own Nginx. You do not need to code your own load balancer, guys, because there are existing load balancers already prepared. You just need to know how to provision them. Or if you do not want to manage them yourself, you can use AWS Elastic Load Balancer. API gateway is different. I'll talk about API gateway after some time, right? So it has a few more use cases. You can club a couple of things together inside an API gateway, like rate limiting can also be done by API gateway, auth can be done by API gateway. I'll talk about the API gateway pattern after some time. Sahil Desal is asking what's the difference between ALB and NLB. So there are actually two types of load balancer. We'll talk about that later as well. L4 and L7. So one is an L4, one is an L7 load balancer. We'll talk about that. Again, Devendra, I already mentioned there will be cost. If you can bear the cost for vertical scaling, that's good. And then there is a physical limit to the most powerful machine that you can provision. Like if you go to instances, launch an instance, you can see like there's a limit, right? That what's the most powerful machine that you can probably provision, right? You can see there are a couple of these powerful machines, but there is also a limit to it. Maybe you have a scale more than that. Guys, we are going to talk about API gateway later. API gateway we will cover later. I don't want to club that as of now. Is AWS already handling most of the system and problem? Are you going to actually work on the system? No. Like for example, if let's say you have a database that you have deployed in one region of AWS, you will be responsible yourself for doing the replication, right? Are you able to get this point? You will be responsible for taking the decision that do you want auto scaling or you want a self-managed horizontal scaling. That's your system design. These are the tools that you will use. It's like मतलब अपना सर्वर लिखने के लिए तुम पाइथन लैंग्वेज यूज करते हो या फिर अपनी खुद की लैंग्वेज थोड़ी बनाते हो. अब पाइथन लैंग्वेज इज द टूल, उसका यूज करके अपना सर्वर लिख लोगे या जावास्क्रिप्ट का यूज करके सर्वर लिख लोगे या जावा का यूज करके सर्वर लिख लोगे. एक एक अपनी लैंग्वेज भी बना सकते हो, बट यू डोंट डू दैट. Okay, we can take a look. I didn't initially thought to add it. Instead, like I thought we can configure things with Nginx, but because that's more of like a algorithmic aspect for it, right? Like, guys, I believe in college, data structures and algorithm, you must have coded round robin and weighted round robin and these kind of stuff, isn't it? Like that's more like the algorithmic aspect. In operating system, everybody learns that. I can share some resources, but let's see if we have some time left, then I can help you with the coding of that part. But I guess that's more the algorithmic aspect. If you want me to cover it, then if we have time left, I'm not saying that we'll definitely do it because I didn't add it initially. If we have time left, then maybe we can do it. But I believe everybody does that when they learn DSA. It's kind of like for example, just going a little bit off topic. You have caches, right? So you have a lot of cache replacement policies, LRU cache, LFU cache. Now coding an LRU cache you already do in DSA, right? And coding an LFU cache you already do. But most of the people like probably don't understand how to change these replacement policies, right? Sure, Samad, I'll do that. Sure, Kash. Makes sense. Now there is one more interesting aspect of the system. There is one more interesting aspect of the system that we call as fault tolerance. This is also a very important, and I would say this is kind of like something which is definitely required in most of the systems as a non-functional requirement. What is fault tolerance? The name already suggests itself, right? Fault tolerance in design refers to the ability of the system to continue operating even if one or more component fails, right? And this is very much related to high availability, because high availability also tries to achieve something like this, that in cases of failures you are still able to cater your user, you are still able to cater your user request. Okay, so fault tolerance will be the techniques using which you will make your system, like fault tolerance techniques will help you to make your system highly available as well, right? For example, just think about it, the same Amazon problem, the S3 problem that these companies were actually facing, what mechanism these companies could have taken in order to make sure that in case of outages they still have a fault tolerant system. They could have prepared backup of their S3 buckets in other AWS regions as well. That's it. That can be one simple way in which they could have avoided this catastrophe, right? So making a fault tolerant system includes different measures that you probably need to add in order to make sure that you achieve high availability and you have as less downtime as possible. Is this point making sense, everyone? So a few techniques can be something like replication, right? You have your data backed up and replicated all together. Another technique can be load balancing, right? Load balancing can help you is aspect of scalability as well, and it's an aspect of fault tolerance as well. That let's say one of your application server goes down due to any XYZ reason, you have more application servers also ready. Just think about it. There is one more problem with vertical scaling, that in vertical scaling, if you just have a single server running up, this and due to any reason, maybe due to a logical failure, a request came up and there was a logical issue in your code, and because of that request, the server crashed. Now nobody else will also be able to interact with your system. This can actually lead to a SPF, single point of failure. But in horizontal scaling, let's say that logical issue happened in this particular server. These two servers are still up, right? And we can actually set up right amount of monitoring to make sure that, okay, we are alerted, hey, this server is down. We can check the logs why this server is down, and then very quickly we can make a code fix and redeploy on all our instances and bring this instance back up again. So again, load balancing can be a good technique to have fault tolerance, right? Apart from that, keeping backup systems ready, right? Keeping backup systems ready is something that can make your system overall fault tolerant, right? Having right monitoring so that you know something has failed, right? Having the right monitoring setup to know something has failed, again, is a good amount of fault tolerance altogether, right? So fault tolerance are just techniques which will help you to achieve high availability, right? And this makes your system still workable in situations where some failover has actually happened. Getting my point, guys? Everybody? Yes, snapshotting also can actually help. Like you do some kind of a checkpointing, right? That okay, this all of these data was actually there. Like you do daily backup, that can also be some sense of snapshotting or some sense of checkpointing and so on, right? So that even if you lose data, you do not lose like everything out of it, right? Let's say you have logs, so you keep logs of last 7 days. So in case some similar issues come up, you are still able to see all of your last existing 7 day logs, right? So these are different mechanisms that can help you to make your system fault tolerant. Any questions, anyone? What is an instance in a server? Generally, we refer to the instance as the machine on which the server is running. Okay. If one of the server crashes, then the request which already passed to it, how that request will fail. So again, you have to think about it. Like, are you okay that in case some request fails? If not, then you have to set up retry mechanisms. Pawan Patil is asking if one of the server crashes, then the request which was already passed to it, how they will be handled? They will fail. So either you set up retry mechanism, maybe on the client side, right? There are a lot of retry libraries and everything. Okay. Like if a request failed, then you can set up some retries. So you have to think about it. Instance, server, machine, all are the same? No. Okay. So if you guys don't know what is a server, I'll just give you a quick detail. So there are two important terms, client and a server. What is a client? Client is any process running on a machine which is capable of raising a request. Server is any process of running on a machine which is capable of accepting a request, processing it, and sending a response back. Right? So when we say instance, instance is the term which we generally use to refer to the machine on cloud platforms. Server is generally the process running on a particular machine. A lot of time you will find people referring the whole machine as server as well. So these are just terminologies to refer to something which is capable of accepting a request, processing it, and sending a response back. But if you talk about nitty-gritty details, server is any process running on a machine which accepts a request, process it, send a response back. Client is any process running on a machine which is capable of sending a request. Machine is where these processes run, and instance and machine is generally the same thing. If you like, you talk about like specifics, but a lot of time you will see people saying that I have 5 servers running on AWS. They then at that point of time refer to 5 instances of EC2 machines running on AWS, but again they say as 5 servers. So it's just something to say about. Got it? Make sense, everybody? Any questions so far? Any questions so far, guys? Okay. Now, if not, then I have a homework for you guys. There is one more important aspect of the systems, which we call as reliability. Okay. Read about reliability. Read about reliability. So there are a couple of homeworks. I would like to list down all of them here. Okay. So read about reliability, what reliability is, and what are the situations where probably you need a pretty reliable system. Mostly always, but still read about what is reliability. Second homework, that is a bit more practical homework. Again, I'll put up a solution, I'll upload a solution for this as well. But what I want you guys to do is try to set up Nginx as a load balancer on an EC2 machine. Okay, so maybe make a new AWS account and try to set up Nginx as a load balancer. A pretty, it's a very simple library to set up. You can just Google how to set up Nginx as a load balancer and you'll get like tons and tons of articles. There is a nginx.conf file that you have to just update. So just see, just try to set it up. I'll of course upload the solution and show you how you can set up your own Nginx as a load balancer. Okay, so this is going to be kind of like a practical exercise that you guys can do, and this is something that you guys can read and we will talk more about it. Got it? But whatever other things that we talked about, I believe that is all making sense. Functional requirement, non-functional requirement, availability, the nines, maintainability, scalability, right? Horizontal scaling, vertical scaling, auto scaling, right? Fault tolerance, right? All of this is making sense, everybody? Fault tolerance is the capability of the system here, capability of the system, so that the system still works in case of failover. So you set up backup mechanisms in case something wrong happens with the system, your system is still working. So you do different things to set up fault tolerance. One of those can be load balancing. Make sense? When you say war instances, do you mean warm instances? Like, yeah, warm instances, right? So deciding between ASG, that is auto scaling group, versus warm instance, is it like event dependent? Yes, you have to decide it yourself, right? Like for maybe Black Friday sale, we know there will be a lot of users coming up. Why do you want to go with auto scaling group? How about you keep some instances ready? Yeah, Gagan, we will be talking about different aspect of this interviews as well in every class. Like today we talked about how do you go forward with this functional and non-functional requirement. We'll be talking about these aspects in every class. Make sense? Okay, cool. That being said, let's wrap today's session here. Are we going to get the notes? Yes, we will get the notes on the platform itself. Uh, No. So there will be some homeworks that I will give you, mostly related to playing around with AWS, right? And then I'll be uploading some solutions for that. Maybe if there is something, some interesting case study or something that I found later, maybe I can just quickly upload a lecture out of it. But a lot of things we are going to discuss like live. There will be a lot of live demos also that we are going to do, like maybe trying out things with, let's say, Kafka. But let's say if you want to set up your own MySQL instance on AWS, how can you do that? Maybe that we are going to do on the recorded part. So it's going to be a mix of it. Yes, Sahil, you can say that. Keeping them ready is part of availability. No, it's for those people who don't know even like how to write a simple API. It's for those. Okay. So, cool. That being said, some of the notes will be uploaded on the platform only. So you can go back to the lecture and you will see the notes there. That being said, let's wrap today's session here, guys. We are going to meet soon in the next session. Till then, take care. Bye bye. Have a great week ahead and keep coding.